Waste stream assessment (WSA) is a process of characterizing and quantifying the waste generated by a facility or organization. It involves the collection and analysis of data on the types, volumes, and characteristics of waste generated. Field investigations are an important part of WSA, as they allow for the collection of data that is not available from other sources, such as waste management records. The various field investigations involved in WSA include waste sorting. This involves manually sorting waste into predetermined categories, such as paper, cardboard, metal, plastic, glass, and food waste. The sorted waste is then weighed to determine the percentage of each category in the waste stream. Waste sampling. This involves collecting representative samples of waste for laboratory analysis. The samples can be collected from waste bins, containers, or landfills. The laboratory analysis can be used to determine the physical and chemical characteristics of the waste, such as moisture content, ash content, and heavy metal content. Waste generation surveys. This involves interviewing personnel at the facility or organization to collect data on the types and volumes of waste generated by each department or activity. Waste flow observation. This involves observing the way that waste is generated, handled, and disposed of at the facility or organization. This can be done by walking through the facility and observing waste management practices, or by using video surveillance. The specific field investigations that are conducted will vary depending on the purpose of the WSA and the types of waste generated by the facility or organization. For example, a WSA that is being conducted to develop a waste reduction plan may focus on waste sorting and sampling to identify the types and volumes of waste that can be reduced. A WSA that is being conducted to comply with environmental regulations may focus on waste sampling to determine if the waste is hazardous and must be disposed of in a specific way. Here are some examples of how field investigations can be used to support WSA. Waste sorting can be used to identify the types of waste that are generated in the largest quantities and the types of waste that are most expensive to dispose of. This information can be used to develop targeted waste reduction programs. Waste sampling can be used to determine the physical and chemical characteristics of the waste, such as moisture content, ash content, and heavy metal content. This information can be used to identify the best waste management methods and to ensure that the waste is disposed of in a safe and environmentally sound manner. Waste generation surveys can be used to collect data on the types and volumes of waste generated by each department or activity. This information can be used to develop waste reduction programs that are tailored to the specific needs of each department or activity. Waste flow observation can be used to identify areas where waste is being generated unnecessarily or where waste is not being handled or disposed of properly. This information can be used to improve waste management practices and reduce waste generation. Field investigations are an essential part of WSA. By collecting data on the types, volumes, and characteristics of waste generated, field investigations can help organizations to develop and implement effective waste management programs. Waste stream assessment (WSA) is the process of characterizing and quantifying the waste generated by a facility or organization. It involves the collection and analysis of data on the types, volumes, and characteristics of waste generated. WSA is an important tool for developing and implementing effective waste management programs. The process of WSA typically involves the following steps. 1. Planning. The first step is to develop a plan for the WSA. This plan should identify the goals of the WSA, the types of waste to be assessed, and the methods that will be used to collect data. 2. Data collection. The next step is to collect data on the waste generated by the facility or organization. This can be done through a variety of methods, such as waste sorting, waste sampling, waste generation surveys, and waste flow observation. 3. Data analysis. Once the data has been collected, it needs to be analyzed to identify the types and volumes of waste generated, as well as the characteristics of the waste. This information can be used to develop a waste stream profile. 4. Reporting and recommendations. The final step is to prepare a report on the findings of the WSA. The report should include a waste stream profile, as well as recommendations for waste reduction and management. WSA can be conducted at different levels of detail, depending on the needs of the organization. A basic WSA may involve a simple waste sort to identify the major types of waste generated. A more detailed WSA may involve waste sampling and laboratory analysis to determine the physical and chemical characteristics of the waste. WSA is a valuable tool for organizations of all sizes. It can help organizations to identify the types and volumes of waste generated, understand the characteristics of the waste, identify opportunities to reduce waste generation, develop and implement effective waste management programs, comply with environmental regulations. Here are some examples of how WSA can be used to benefit organizations. A business can use WSA to identify the types and volumes of waste generated in different departments. This information can be used to develop targeted waste reduction programs for each department. A municipality can use WSA to develop a waste management plan for the community. The plan can identify the best ways to collect, transport, and dispose of the waste generated by the community. A manufacturer can use WSA to identify opportunities to reduce waste generation in the production process. This can save the manufacturer money and reduce its environmental impact. WSA is a valuable tool for organizations that are committed to reducing waste and improving their environmental performance.